All right, so these are the two things, what we talked about, like the names of polygons and stuff yesterday. But then we got two formulas, right? One was, which was the sum of the interior angles in a polygon. And what's that formula?
N minus 2 times 180.
Good. So sum interior n minus 2 times 180. And then we did each interior. Good. What had to be true about the polygon in order to do this? Do you remember? Each, but also it has to be regular. All the sides and all the angles have to be the same, right? Otherwise, there's no way for you to figure out an individual one. So number 1 says find the sum of the interior angles. So again, you want to look for those keywords because they're going to change. Sum, which means you're leaving that initial equation, and then interior because today we're going to add exterior. And what's a heptagon? 7 sides. So I do 7 minus 2 times 180, or 5 times 180. 180 times 5, 900 degrees. Okay, number 2 says find the measure of each angle of A, and this should actually say regular 20gon. So each angle in, there's your interior, okay? And a regular 20gon, now my n is 20, minus 2 times 180 over 20. So I get 18 times 180 over 20. And we said yesterday, you can either simplify it as it is, like I can cancel out the zeros here, and then say 12 goes into 2 goes into 18 9 times, and I can do 18 times 9 and get 162. Or you can multiply out 180 and 18. So I would just bring down the 0. $3,240, and then divide it by 20. So I would cancel out the zeros again, make my life a little bit easier. And then I would do 324 divided by 2. Either way, you get the same answer, which is 162. Questions so far? Okay, so we're going to finish the notes that we started yesterday, and then I'll go over the homework that was due this morning. So if you've got any questions, you can do that too. Okay? So we left off yesterday with the exterior angle, right? We talked about what the polygon were, the names of the polygons that you need to know, the sum of the interior. We worked with this example and this one. We did the corollary, which is the each interior. We worked those examples, and then we left off here. So theorem 6.2, which the number here is not important at all. It just means that this is the second theorem that's mentioned in chapter 6. What is important is what it says and the name. So Polygon-Angle Sum Theorem has a lot of words for one simple concept, which is that all the exterior angles in a polygon sum to 360. So the sum, again, important word sum, which means if I added them all up, measures of the exterior this time of a convex polygon, one at each vertex, is 360 degrees. So if this is my initial polygon in here, this is my convex polygon, how many sides are there? 5. There will be exactly as many sides as there are exterior angles. So the number of sides is the same as the number of exterior angles. If you extend the sides like they do, then everywhere there's a number there, that's the actual exterior angle. So this is an exterior angle, this, and this. If I extend the side, the angle that's formed by meeting that extension with the side is your exterior angle. And those would sum to 360, no matter what the number of sides. Raise your hand if you're still coming down. So example 4 says find the measure of each exterior angle of the given regular polygon. So now it says each, right? I've got each and I've got exterior. A says octagon. How many sides are in an octagon? 8, which means how many angles are there, exterior angles are there in an octagon? 8. What's the sum of the exterior angles in an octagon? 360. So if I wanted to find out how many each of them would be, what do I do with that 360? Good. Divide it by 8. So each exterior is going to be 360 divided by the number of sides. So 360 divided by 8 is 4, 0, and 5. So each exterior angle of a regular octagon, regular because they'd all be the same, is 45 degrees.
If they just say the given polygon, you can find it.
Yeah, no, it has to be regular in order for them to be the same. Yep. All right, so B says 28 gone. What do I do with that? Good, N is 28. So I have to do 360 divided by 28. So 360 divided by 28 once. How many times do we think 28 about goes into 80? Like 30, about 30 into about 80, which would be what? What would be 3 times 30? 90, too big, right?
Yeah.
What would be 2 times 30? 60, so somewhere in between there, right? So let's try 2. Have to bring it down again. Too big. So I can keep going, right? Oh, my decimal's here. Or what could I have done with my remainder? If I had had 12 and my remainder there was 24, I could have put 24 over 28. And I could have reduced it, right? So this would be divisible by 2, that's 12, and this by 2, that's 14, and then do it again, 6 and 7. So you think 6/7 is easier to write than a repeated decimal that's going to go on and on and on? Probably yes, right? So sometimes the numbers are yucky, you just got to keep going. My advice would be to leave it as a fraction instead of as a decimal, but if it's an easy decimal or you're more comfortable with decimals, then obviously you can feel free to keep going. But you would have had to keep going there.
How do you get the 24?
So it was 2. Okay, last one says the sum of the interior angle measures of a polygon with n sides is given. Find n. So think about what it's asking. What do we know about the sum of the interior angles? What's the formula for sum of interior?
N minus 2
n minus 2 times
times 180.
180. So if this sum, right, is normally what we're finding, this time they're telling us this is the sum. So 1980 is the sum of this, which means I would do n minus 2 times 180 equals 1,980. Now the variable is the n, and that's what we're looking for. So there's a couple of things I can do here. What's one of them?
Go backwards.
Like what? Like what would be first step? Because you really have 2 choices. You can divide both sides by 180. You can't subtract. You would have to distribute before you did that. So I can go from here, this would be n minus 2 equals, and then 1980 divided by 180. I can cancel through my zeros, and then I would do 198 divided by 18 once, and once again, and that's 11. And then how do I get the n by itself?
You add 2.
Good. Add the 2 to both sides. So these cancel, n equals 13. So that's one way to do it. Immediately divide by the 180 and then add the 2 to the other side. The other way to do it is take this and distribute your 180. So I'd get 180n minus 360 equals 1980. Add the 360. But then I'm dividing by 180. So it can be done that way. Okay, I would again cross through my zeros, and then I would divide that into it. It'd be 13. Probably easier to do it the first way, especially if it's divisible. And think about what your answer should look like. Could you have a polygon with 2.5 sides? No. 10.2 sides? No. So these answers, these kinds of questions, when it's asking for the number of sides, these should always be whole numbers. So it should be easy to divide into it, okay? So think about the types of questions and pay attention to the wording, because this one said the sum was given and you were looking for the actual number of sides. Questions? Okay, so this is what it looked like. And yesterday I told you guys to work on this first page, right? Because this was all the stuff involving interior angles. And then we're going to move on to exterior angles. So did anybody run into a question they didn't understand how to do from yesterday? 15? Okay. So, yes, 15 and 17 say to find the missing angle measures, right? What did we say we had to do first in order to know what those angles would be on the inside?
360.
Good. You got to figure out what the sum would be first, right? And we said if it's a quadrilateral, which this one is, that the sum would be 360. Okay, if n is 4, then my sum is 360. It's a quadrilateral. Okay, it's a common one. So I said yesterday, if you want to memorize it, that's probably a good idea. So then if I have those 4 angles inside and they add up to 360, then I can say h plus 2h plus 2h plus h should equal 360. So then I get h plus 2h, which is 3h, plus 2h, which is 5h, plus h, which is 6h, equals 360. And then take and divide both sides by 6. H is 60 degrees, right? So this one's 60, this one's 60, this one would be 2 times 60, or 120, and this would be 2 times 60, or 120. Yep.
So the H represents like 1,
Yeah, like there's in front of the H would be a 1. Is that what you mean?
like H plus 2H, like you said was 3, right?
Yeah. So when there's nothing on the front of the variable, there's really a 1 there.
So your answer is h equals 60.
Because it said find the missing angle measures. So it's 60, 60, 120, and 120. You actually want the measures. Obviously 17 was a little bit trickier. How many sides are on 17?
7.
1, 2, 3, 4, 5, 6, 7 sides. So I have to figure out the sum first, right? So n minus 2 times 180 would be 7 minus 2 times 180. We already did this, right? We did this in the warm-up.
Yeah.
And it's 900. So then if I know all of them except for this one, I have to take and add 120, 116. Let's do them piece by piece. Those are those two. Then add 129. That's that one. Then add 130. Then add 135. Then add 125. And then subtract that from 900. Oh. Yes.
Why'd you do the equation for n minus 2 times?
Because we have to figure out what all of them inside should add up to first before we can start to take the rest away. Any other questions from the stuff from yesterday? Oh, the